right, everyone, thank you so much for joining me tonight. This is a presentation of the Florida West Coast Section IEEE Computer Society Group. Okay? What are we going to do tonight? We're going to talk about dimensional things. So that's got to be a good thing, right? A really cool piece of software called Tinkercad, which is made by a company called, interestingly enough, AutoCAD. And everybody knows who AutoCAD is because they make probably the most popular design piece of software. Really, though, expensive. If you've ever seen how much AutoCAD costs, it costs a lot. It does a lot, yay, but it's really, really super expensive. The cool thing about Tinkercad is that it's completely free. And they've worked a lot with it. So it's a great tool, and that's what we're going to be covering tonight. Now, Google Meet is a fickle beast. And so what I'm going to do here, we can turn off my camera, just because my bandwidth might not do it. So let me go ahead and admit somebody who's joining our meeting here. Let me go, I am sharing my dashboard, hopefully, my screen with you. So I'm going to assume that when you look at your screen right now, you can see a blue plane with a little square in the middle. Could somebody go off mute and confirm that that's what you see? It is?
We see that.
All right, good. Otherwise I'll spend the next 45 minutes talking to myself, which is fabulous, but probably not all that good for you. All right, so this is Tinkercad. You can see the Tinkercad logo up here. Actually, I can probably go here and show you. Let me go to Tinkercad here. So I'll show you what Tinkercad looks like before we go jumping into it. That probably seems like a better idea, too. Give me just a moment to get my act together here. Maybe So if I wanted to find out about Tinkercad after this presentation, what do I have to do? Very simple. You got to go to a website. The website, interestingly enough, is tinkercad.com. And it's a pretty, considering it's free, it's actually really pretty slick. Boop, and here we go. And I guess I'm already logged in, so that's why I get to see this. So I get to see my recent designs, anything that I've created. I can do other things with circuits. I can do some stuff with code blocks. If I want to instruct children, I can do a whole bunch of stuff, etc., etc., etc. And this is just going to show all the different things that I've actually been working on lately. Chink, 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 chink. Say, what the heck? Let's get started with what we're going to do tonight. So what I wanted to do tonight is sort of take you through some of the basics of Tinkercad, show you sort of how the tool works. This is all very fundamental stuff. If you log into Tinkercad, you can reproduce everything that I'm going to show you tonight. When we get through all the sort of like how do things basically work stuff, the next thing I'm going to do is I'm actually going to do a Tinkercad project. I'm actually going to go ahead and build something in Tinkercad. When I get done with it, I'm going to download the design, and I'm going to show you, if this works out, fingers crossed, toes crossed, how I could actually use that design to do 3D printing of whatever I've created. So I've got lofty goals for tonight. We'll just have to sort of see how this works out. So in this demo, to get you sort of comfortable with Tinkercad and sort of how stuff in Tinkercad works, it's pretty simple. It wants me to take a box from the right-hand side of the screen. So I'll come over here and I'll go select on box. I have a whole series of shapes that are available to me. Cones, a roof, a rounded roof. I can do text, a wedge, a pyramid, a tube, a bunch of stars. I have a whole bunch of predetermined shapes that I can use if I'm building something. In this case, I want a box. So I'm going to grab a box and I'm going to bring it over and I'm going to drop it on my work plane surface. Boop, there we go. Now, the goal of this particular exercise is simply for me to take the box that I have and place it inside of what they call a hint, basically the orange box in the middle. They're just trying to make sure that I know how to use my mouse and stuff like that to move boxes around. So I can move the box literally anywhere I want. And knowing me, dimensions off of a line. I'm negative 73 up, 77 down. But here we go. Now I can just move it right over that. Chink. Poof. And that's it. Just showing me how I can move shapes around on the work plane. If I wanted to do something with a sphere, I could do the same thing. So I could grab the sphere shape, put it down, and I could just move it around and place it anywhere on the work plane that I wanted to. Could do the same thing with the cylinder, just because it's cool to do that. And what the heck, we'll do it with a cone, just to sort of round out our shapes. And you can see that everything's 3D, so that's sort of cool. All right, it's a pretty graphical program when you consider I'm really literally just running it in a browser. All right, if I click to my next, it says, congratulations, you successfully put a box in the middle of the hint. And so that was good. So it's just telling me that I did it correctly. All right, so that worked out pretty well. Let's go on to our next one and see what we have for ourselves. So the purpose on this one is to show me how I can view objects on the work plane differently. You'll see in the upper left-hand corner, I have this sort of box that says top and front. I can rotate this box, and as I rotate this box, this entire plane is going to rotate. So here we go. So the box that I have here is labeled top, front, probably some other things too. So as I rotate the box in the upper left-hand corner, you'll see that the whole plane rotates. So if I want to take a look at the sides, I can just move my mouse to the right. It says left. Now if I move my mouse to the left, it's going to say right. I can move back, see it says front. And I'd like, hey, does it say something on the bottom? Let's find out. Boom, it does say something on the bottom. I wonder if it says something on the back. So maybe I can rotate my mouse enough. Oh, there it is. Hey, it does say something on the back. How cool is that? So you can see that when I put my mouse on the box in the upper left-hand corner and I move that box, it causes the entire plane to move. Now, something else that I can do is I'm on my keyboard. You can't see this, but on my keyboard, I'm pressing and holding Control. And now I'm moving my mouse. So the same thing can be done just by using my keyboard. I don't actually have to use the box in the upper left-hand corner. Although the corner does rotate to show me what my current orientation is. Well, that's just pretty cool, man. That's very 3D, right? That's another way. So I have two ways that I can cause my work plane to rotate. I can do the box in the upper left-hand corner, or I can press Control and move my mouse. Just because it's no good when you only have two ways to do something, we also have a third way to do something. What I'm going to do right now is I'm going to press my right mouse button, and now I'm moving my mouse. And you can see that it rotates also. So really there are three different ways to do exactly the same thing, which is basically to rotate the work plane so I can look at what I'm building from a whole bunch of different angles. The fact that there's three different ways to do exact thing should probably be sort of a clue that you do a lot of it. As you're building something using Tinkercad, you always want to be taking a look at it from this angle or that angle or something like that. That's why they gave you three different ways to do exactly the same thing. It's whatever works best for you is the thinking. Now, the little box that's sitting out there is actually pretty far away. Okay, I wish I could see it closer to say so I could see more details. And what I'm going to do is use the scroll wheel, that's probably the way to say it, on my mouse to zoom in. So just by doing my scroll mouse button, I can actually zoom in. And if I right click on my thing, I can now cause it to rotate. And we can see that we have on each side. And it's really big because I went in so close. Now if I wanted to go back out, I will just use my scroll button, wheel, and it'll take me back out. And then I can do a little rotate to get a little 3D action going here, and there we go. So that's pretty cool. Yay! So I did that one successfully, yay! So you get a feel for what you can do. So clearly we have full control over how we're viewing whatever we happen to be building. So that's sort of cool. All right, what's this one going to be? This is going to be move it. So the concept here is I want to be able to go ahead and actually move things that are on my thing. Oh, somebody wants to join. That's why I was checking that. All right. Apparently I have to stay up on that. All right. Oop, here we go. So I want to move. I have these shapes. I have 4 blocks on my work plane, which is great, but I've decided to make a change in how I want to do things. So I want to move them from where they are to where I want them to be. So now I've got these hints as to where I want to move them. So what I'm going to do is I'm going to go ahead and I'll select this box, one of the 4, and then what I'm going to do is I'm actually going to move it and place it right there. Actually, what I ended up doing was just copying it. Now I'm going to go ahead and select this one, and I'm going to move it to occupy this space. I'll do the same thing here. Select it, and then I'll just move it out and have it occupy the hint space. And one more. Grab it, and then move it. Boom. That worked pretty well. Now, it's making it a little bit harder. It has actually moved the hint, so it's actually hovering above the plane. And it wants me to move my boxes so that they will actually have some altitude. And they will actually fill the boxes that are up there. So how am I going to do that? Well, I will first off select a box. And you'll notice that I have this black arrow here. And this black arrow allows me to move my box, the whole thing, up. Chink. So I'll come over here and I'll select this one. Get a black arrow. And I can move up. Now I want to do these guys who are currently in the background. Oh, well, it's a bummer they're in the background. How about if I rotate? And actually, this one is the one I want to do, so I'll just sort of hang out here for a little bit. So I'll select him. Oh, I didn't do the right thing. I didn't grab my black arrow. How about that? Okay, now I'm grabbing my black arrow. Chink. All right. Oh, I want to do this one. Oh, but it's so far away. Well, all I really have to do is do a little bit of rotation. Oh, black arrow again. Here we go. Pow. There we go. So I can levitate any of these boxes. And so like these ones here. Oh, I think I selected the wrong thing. There's its black arrow. There's no hint boxes to move into, but you get the gist of it. Any shape that you have on the work plane can be given altitude. And there we go. We have the amazing levitating boxes. But it just shows you that when you're using Tinkercad, you're not building in 2 dimensionals. You have the ability to build actually in 3 separate dimensions. Your design can actually have height to it. So that's sort of cool. Yay! We were successful. How cool is that? All right, so we got that taken care of. What's next? Okay, so we have 3 boxes here, but we have outlines of shapes that we would like to rotate the boxes into. All right, so what we want to do is grab the boxes and rotate them. So let's see how we do that. That seems like that could be a little bit hard. So let's zoom in a little bit here. Zoom out. There we go. Okay, that seems like that's pretty good. All right. All right. So I want to rotate this box, and I want to rotate it, what, 45 degrees? Probably. So you'll see up here at the top, after I select it, I have this curved line. We'll call it a curved line. And when I, pardon me, when I move over the curved line, obviously a radius, a turn radius shows up, saying that I can actually rotate the box. And the radius is actually a pretty small area, so I have to be a little bit careful with this. So let me see if I can get it to show up, and then I'm going to rotate my box. There we go. I rotate it 45 degrees. Fantastic. Now the original box is still there, which is just annoying. So let's see if I can make it go away. There we go. So that's my rotated box. Woohoo! Now I got different rotations to do. So let's come over here. This box is going to rotate, but it's sort of like rotating sideways. So once again, I'll select it. I'll go up here and I'll get the rotation lines to show up. And I will rotate it 45 degrees. I will then select the original box and make it go away. Cool. All right. Second rotation success. And what do I have here? Oh, okay. So this I'm rotating in yet another plane. All right. So I will now select this box. And here's the rotation over here. I will rotate it like that. Then I'll come along and select the original box, make it go away. And bam! There you go. I have rotated all three boxes. So what that means is in Tinkercad, when you have a shape on your work plane, you can rotate it however you want, really. Which brings up an interesting point. So, I mean, we had fun with boxes, but what if I brought something like a cylinder there? Well, look, the cylinder has the same bent line. Here, let me do this correctly. Once again, it's a small little window to get in there. Ever so gently. So much for my ability to grab the rotational. It was going to be a really great demo if I could do it, but maybe I just need to get in there closer, make it more of my screen. Here we go. It desperately doesn't want to stay for me. Oh, that could cause me some... Oh, there we go. Oh, look at that. All right, cool. So there we go. I'm rotating the cylinder. I am completely rotating the cylinder, of course. But then I can also rotate the cylinder just like that. Poof. All right. So just showing, of course, that you can rotate any shape that you want. Pretty cool stuff. All right. You gonna congratulate me for successfully doing it, please? Yay! All right. So we got our shape rotations done. Once again, just showing things that you can do while you're designing your 3D shapes using Tinkercad. All right, what else we got? We want to resize a shape. Okay, so I basically have square block holders here, but they're all bigger or wider than a square block. All right. So I want to drop a block in and then resize the block to get it to look the same size as the shape. Okay. So we'll come over here and we'll grab a box. Poof, like that. All right, I want to move the box inside of the hint. Now, that's great, but I need to basically be able to get the box to fill the space. So I'm going to have to change the dimensions of the box. If I take a look, it looks like the height is fine, right? My box is tall enough, it fills the top of the hint, but it's not wide enough, right? I need to go off to the left and I need to go off to the right to make this thing work out. Top is probably the best way to view this. Sorry, don't mean to make everybody nauseous. There we go. So what I'm going to yeah, that seems pretty good. So I'm going to select the red box. Now notice after I select it, a whole bunch of things show up. You know, obviously I've got my little bent shape that says, hey, if you want to rotate it, that's cool. This time I don't want to do that. I also have a series of white dots and I have a series of black dots showing up. For this activity where I want to change the shape of it in one direction, I want to use the black dots. So I'm going to grab a black dot on the left hand side and I'll extend it there. I'll grab a black dot on the right hand side and I'll extend the shape to go right there. And I think I did it. Look at that. My box fills it. Well, that's cool. I got a couple more challenges, so let's go for that. So we'll come over and grab a box. We'll drop the box right there. Chink. We'll move the box inside my hint. Yay. Now once again, I'm going to grab the black dot, not the white dot. Move it to there. Come over here and grab the black dot, not the white dot. Oops, and move it to there. Perfect. Excellent. I only have one hint shape left to fill. All right. Well, how hard could that be? Pfft, not very, thank you very much. So I'll go ahead and grab a box. I'll bring the box over here. Chink, chink. I'll drop the box inside. I think I'm still good as far as height. Yes. But now I've got, obviously 2 dimensions that I have to fill my box up in. And I could grab my black handles and do it. But quite obviously, I'm going to have to grab all 4 black handles and drag them in 4 different directions, which is fine, but a little bit of a pain in the butt. That's why I've got the white handles. Because if I grab the white handles, I can get the box to expand in 2 directions at the same time. So if I grab the left bottom one, I can get it to expand in 2 directions there. If I grab the white handle over here, I can expand in both the right and the top directions. And when I do that, I think I'm good to go. Look at that. So black dots and white dots that show up when you selected a component, a thing, allow you to change the size of your pre-configured 3-dimensional object. Well, that's pretty cool, isn't it? Not too shabby. Did I do it right? Come on. Oh, look at that. I did. I did do it right. Yay. All righty. Well, that's going pretty well. What else we got going on for us? Oh, brand new technology. All right, so this is going to be cool. All right. So what we got going on here? Well, we got basically 2 sets of 2 shapes that are in the same place. There's nothing more fancy than that. Okay. Oops. I think I got somebody who's trying to get in. Cool. All right. So in this demo, what we're looking at is on our work plane, we've got 2 boxes, and the boxes seem to have cylinders stuck in the middle of them. So let's see. I bet I can probably select this box. Can I move the box? Well, I can actually. So there's just a cylinder, and there's just a box here. Nothing big. They're just occupying the same spot. Chink, chink. Well, maybe I want to build a cylinder box for whatever reason. But when I start doing things with it and getting all fancy with it, I don't want to have to select the box and select the cylinder. You saw me move the box, and the cylinder just sort of sat there. Hey, what up with that now? So what Tinkercad allows me to do is to come along and draw a box. I'm just pressing my left button down, and I'm going to select everything. So I selected both the box and the cylinder, and it's a little subtle, so I'm sort of pointing this out to you, just a little subtle. The box now has a blue line around its edge. If you look real close, you can sort of see that, right? That means I have selected the box. The blue line means the box is selected. Now what hopefully also you can see is that the cylinder has a blue line around it also. And what that means is that I have selected both the box and the cylinder. Two two objects. There's 4 objects on the plane. 2 have been selected at the same time. Now I'm going to go here in the upper right-hand corner, and I'm going to select the group icon. Okay? I'm going to say group them. Now, they got grouped together. Notice that the color changed. Remember, the box was red, and the cylinder was gold. I'm stretching a little bit there, but you get the gist of it. Now, those 2 items in the world of Tinkercad have been joined into a single item. And what that means is if I select it and I move it, they will both move. Remember, last time I did this, just the box moved and the cylinder stood there. But because I have grouped them, Tinkercad now considers them to be the same thing. All right, well, that worked out pretty well. Now we're going to do a little something that's going to blow your mind, because it's just really that cool. So what do we got going on here? Well, I've got, obviously, a red box, and I apparently have like a gray, cylinder? It's round, stuck in the middle of it. What's up with that gray cylinder thing? Well, interesting enough, yeah, it is a gray cylinder, but it's a very special type of cylinder. It's a cylinder. Here, I can even show you how this gray cylinder was made. So somebody selected a cylinder, they brought it out, and they went over here and they said, hey, this cylinder, I'd like to turn it into not a solid, which is what it is right now, but I'd like it to be a hole. And once they did that, poof, it turned into a gray thing. So when you see the gray shape, you know that it's a hole. Well, how cool is that? So I have a hole and a box. All right, well, let me go ahead and select both of those. All right, notice that we have the blue line around the box indicating it's selected, and we have a blue line around our whole cylinder. All right, we can see it pretty clearly when we look from the top. All right, so everybody's there. Now we're going to go ahead and group them together. So I'm going to say group. Hey, what happened to my whole cylinder? Well, interesting enough, it went away. But even more important than it going away, when it went away, it took part of the square, of the box. What that means is now my box has a hole in it. So when you put a hole shape into another shape and then you group them together, the hole shape will remove a portion of the device, of the shape that it's actually touching. And that's how you can make things like holes in solid 3D shapes. How cool is that? I just say that's cool. Yay! We were successful. Yay! That is just neat. I want to copy things. Okay, so this is just sort of speeds things up. If you're doing a lot of 3D construction, and for example, you've built something that you really like, and now you need like 4 more of it, you have the ability to copy things. All right, so we've got a hint here. So we'll come over here and grab a box. Bring the box right there. Chink. We're going to put the box into the hint. Dun, 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 dun. Chink. All right, so we got that taken care of. Oh, now we got more hints. Uh-oh. So what am I going to do? Well, I don't have anything selected right now, so I'm going to move my mouse over the box. I'm going to select it. Click. I'm going to go to the upper left-hand corner. I'm going to select the icon to copy. Click. And what happened? Absolutely nothing. But I have made a copy of my red box. Well, I've got 3 things to fill up here. I'd like to have a copy. I'd like to use a copy of that. So I can go over here and I can press the paste icon. And it pastes a copy of my box there. Well, fabulous. So I can take that copy and I can put it right there. Woohoo! Now, there's another way to create a copy. I can, on my keyboard, I can hit Control V. And it's going to paste a copy of my copy. But that's fine. I can take that. I can use it to fill the second one. What happens when you make a copy of a shape and then press paste more than once? Well, I'll show you. 1, 2, 3. So I can keep pasting until the cows come home, basically, right? And that gives me a whole bunch of versions of my red box that if I was building a house, a farm, a car, I could certainly do something with, right? So you select something, you press copy, and then after you do that, you hit paste, and you get another version of whatever it was that you selected. How cool is that? All right. Duplicate it. Oh, which is sort of like copy, but it's a little bit different. All right, so what we're going to do, well, let's select, we've been doing a lot of boxes. Let's do something with a sphere. So I'm going to get a sphere and stick it there. Chink. Hey, nice sphere. Thank you. Okay. So what are we going to do now? So we having selected it, I'm going to go up here and I'm going to select duplicate. All right. And guess what? I've got a copy of it. Now, if I choose to change this sphere somehow, make it a little bit more oblongy. Okay. And I'll give it a little bit of height too. Now, if I come back up and hit duplicate again, it's going to make a copy of the sphere, but it's not going to make a copy of the original sphere. It's going to make a copy of my copy. And my copy has been changed from the original sphere. And Tinkercad remembered my changes. So what it's going to do is it's going to take this version of my sphere and apply the same changes to it and make another version. So let's see how that works. Boom. So that one's a little bit farther off the plane. It's a little bit larger. So that's sort of cool. What happens if I do duplicate again? Boom, and it's even farther off the plane, and it's even larger. So duplicate keeps doing the same changes that I did as I made my duplicate, and it applies them again and again and again. And so on, and so on. You get the gist of it. So I have the ability to basically make some changes and then replicate those changes potentially on different size objects over and over again. I'm not exactly sure what context you would use that in, but if you wanted to do it, it sounds like it's a pretty valuable tool, right? Not bad. All right, what do I got here? Now I pause for a moment because I've tried doing this one before and I've done it wrong every single time. So I don't know if I'm actually going to be successful for it. The concept's actually really super simple, but for some reason, because I don't know, fat fingers or something like that, I do a bad job on this one. So I will just tell you that beforehand, and if I'm successful, we will all be amazed. So it's a box that clearly has stuff in it. So what I would like to do, and what I generally don't do a good job of, is I'd like to select the box. And I'd really like to select just the red box. So did I do that? I think I see the blue line of selection all around the box. So I think I have done it successfully. Okay, so that's good. And what I can do is I can unhide the things inside of it by hiding the red box. And I do that by coming over here and selecting the light bulb. And that's supposed to hide the things that I've selected. So let's give it a shot and see how it goes. See, and that's my problem. It may have hidden something, but I'm not sure what. So I struggle with this feature a little bit. Once again, have I selected the box? I think I have. The box have a... It does have a blue thing on it. All right, so I think I've done it correctly. Let's see if I hide this. Now what happens? Bam! Oh, I did it. So apparently I have to do it twice. Maybe there's two boxes. So these are the things that were inside the box. And when I hide the box, I can see them, and I can probably, can I select them? No. Oh, I guess I can, yes. So I can actually select them. Now remember, the box actually isn't gone. It's just hidden. I think this is the one that brings it back. Yeah, okay. So if I select this, this is the one that hides it. And this is the one, the light bulb that brings it all back. So you're basically indicating that if you're building something using Tinkercad and things are getting sort of complicated and you can't see the part that you're actually working on right now because another part of your design is blocking it, it turns out what you can do is you can select a portion of your design and hide it. It won't go away. It'll just be removed from the work plane so that you can concentrate on what you're really actually interested in. Alrighty. All right. We have one last demo to do. And what we're trying to do, oh, I got to reset this one. Here, hang on. Give it just a moment to get us act together. So we've got a bunch of box, and they're all sort of, we would say, probably on different planes, which is fine. What we would like to do is line them up. And you know, you do this more often than you would believe when you're doing actually a design. You'd like to get things to line up with each other. Not a problem whatsoever. And it turns out that Tinkercad actually gives you the tools to make that happen. So that's actually a cool tool to have. It just makes your life a lot easier when you want to go ahead and do something like that. All right, Tinkercad. Did I screw things up? I might have screwed things up, but that's okay. So what I can do is I can artificially do this. So I will bring a box there, and I'll bring a box there. While that box is selected, I will say I would like to put a little height on it. Bring that box over there. I'll put a little height on that one too. All right, so is anybody lined up? No. Okay, so we can see that they're not in a line. Obviously, they're at different altitudes. All right, that's fine. Well, so how, if I wanted to get these guys to line up somehow, what could I do? Well, here's what I could do. I would select one, and then holding my shift key, I'd select another one, and I'd select another one. So all three of them are actually selected. Notice that Tinkercad's drawing a black rectangle on the work plane showing all three blocks that are currently selected. All right, so these guys are selected, which is very cool. Now I can go over here to the right and I can select the align option. Click. And when I do that, Tinkercad gives me a whole bunch of choices. So do I want to align my boxes vertically? And if so, that's what I can do. I'm sorry, I can actually align them with the tallest box, would be right to say. Now I have another box that's like in the middle, and if I want to align them with that, I have an option to do that. And if I wanted to align everybody with the box that's basically on the work plane, not a problem whatsoever. Now, this box is over to the right the most. If I wanted to align everybody to the right, I could do that. Oh. Teach me to accidentally click the keyboard. Align, please. If I wanted to align everybody based on the middle guy, or if I wanted to align everybody based on the guy on the left, I could do that too. So I've got tons of options here. So we'll go ahead, I'll tell you what, we'll go ahead and align everybody on the middle guy. How about that? Let's click. All right. Now what else can I do here? I could align them on top. I can align them on bottom. I can align them all on the bottom. I'll tell you what, we'll do in the middle. How about that? Do I have that as an option? I think I do. Let's give that a shot. Bam! So we took our boxes that were all willy-nilly this way and that way, and we aligned them, right? We were able to get them to be taking up exactly the same space. They're all lined up with each other. All the corners line up, etc., etc. So Tinkercad makes it very easy as you're building things to make sure that they're in perfect alignment with each other, which is actually something that you would do more often than you would think. All right. Well, fantastic. So that demonstration that we just got done doing had the purpose, or the reason we did it, was simply to show you the capabilities of Tinkercad. You can sort of imagine the different things that you could actually do if you wanted to. This is, I don't know if this is the best way to show it, but let me go ahead and give it a shot anyway. So, just real quickly, if I wanted to build a car, I'd need to have what, like 4 wheels? Got my wheels. All right. Maybe I need to line my wheels up. Oh, wait. Actually, I guess what I could do is align it. All right, I think everybody's nicely aligned. If I was building a car, I'd need to have like a chassis. All right, so there goes my chassis. There goes my chassis. There goes my chassis. I'd need to have like a roof on the car, so I can grab a roof. I'm not sure if that's actually going to work. There we go. We're not really getting that thing lined up, are we? Now we're getting closer. Alright, talk to me. Oop, no. Alright, that's looking pretty good. And we'll bring it down. Ching, 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 ching. Alright. And we know it's not the right size, but that's okay because we know how to do this, right? I'll use my black arrows to stretch it out that way, and my black arrow to stretch it out that way. I need some headlights, don't I? Well, that's not a problem, because I can bring a cylinder here. That's a little bit too big. So let's see if I can shrink up my cylinder a little bit. That seems pretty good. Now here's an interesting point. I apologize that we really didn't have a chance to cover it. So if I select my cylinder here and zoom in a little bit, let me see how I gotta do to get some height values. Notice that it's showing me how far off the ground it is. It's 2, 3, 4, 5, 6, 7, 10, etc., etc. So I can lift it up and it's telling me that. What do I really want to do here? I guess I want to rotate it, among other things. So let's see. I didn't do so well last time I tried to do that. Okay, cool. Excellent. That's pretty good. I don't really want it to be that long. So 20 is how long it is. I want it to be like 5. Poof. All right, well, that's pretty good. Oh, it seems like it's gonna rotate a little bit more. Yeah, me and my rotation problems here. Hang on. Alright, that's pretty good. We'll bring it over here. Oh, you know what I want to do though? I really want to rotate it in a different plane, don't I? I want to zoom in. Somehow I seem to have buried it underground. That's sort of sad. Let's see if I can select it. No, I'm changing the size. Didn't mean to do that. See if it's still underground. It is. That's crazy. Oh. All right, I think things are going crazy for me there. That wasn't really what I wanted to show you, but I did build my car, so I'm sort of happy about that. I mean, it's not really the world's best car, but you saw that I did it in roughly about, what, 2 seconds. So if you wanted to build something, you can do it pretty quick. I wanted to sort of conclude our time together tonight just doing a quick project, okay? What am I going to do? I'm going to build a protractor. You remember protractors from elementary school, probably. You know, use it to do angles and stuff like that. I'm going to do a simple protractor. I could do a complicated one, but I don't really want to do that right now. So here's my work plane. That's where I'm going to be building my protractor. What I'm going to do is, first thing I'm going to go ahead and get a ruler, just to make my life a little bit easier. So I'm going to place the ruler wherever I want my basically origin, the center of what I'm building going to be. So I'm going to say like right there. Seems like it's actually pretty good. Is that? I'm going to say, yeah, well, actually, it looks like I'm off a little bit. So how about if we do like this? Is that good? Oh, that's perfect. All right, so that I want that to be the center of whatever the heck I'm building. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. You know, I think I'm one off. Okay, that's probably a little bit better. All right, so now what I need is a cylinder for building my protractor. I'm going to bring it out here. What do I want to do with my cylinder? I want to resize it. I want it to be 150 millimeters in diameter. Well, you can see on the screen right now, I've got a whole bunch of numbers on the screen. So what do I got? It's telling me I'm negative 68 from the origin. It's saying that I'm 27 up from the origin. Those are interesting, but I desperately don't care about them. It's telling me that my left to right size is 20 and my top to bottom size is 20. And if I want 150 diameter, I'm going to have to change that 20 to 150, which is going to make a weird looking shape. But when I change this to 150 also, I'm going to get me a big circle. Woohoo! Now I'm going to take my big circle and I'm going to move it so that it's centered. Perfect. All right, centered on my work plane. All right. Oh, there's some other stuff I want. Let's see. To make it 150 millimeters in diameter and 3 millimeters along the z-axis. Okay, so I want it to be 3 millimeters tall. So how tall is it right now? Well, over here it's telling me it's 20 tall. Well, that's way too much. I want 3. Boom. All right, so that's pretty good stuff. Now, what else am I missing here? I'd like it to hover above the work plane by 1.5 millimeters. Well, right over here, this 0, 0 is clearly the height, so I'll do 1.5. Poof. And it popped up just a little bit. I mean, not a lot, but that's okay. So we're getting there. Okay. Now, what do I want to do now? I want to put another cylinder to the center of this one. Well, we got cylinders coming out of our ears apparently, so that's fine. Like that. So what does that actually look like? Well, it's like cylinder on cylinder is basically what it looks like. What do we want to do with that one? All right, so we'll just eyeball it and make it sort of nice for us. We want the edge of our protractor to be thin, so what we're going to try and do is come up with a bevel edge. Sometimes this works for me, sometimes not so good. Second cylinder, we want to have 160 millimeters in diameter. Whoa, so the other one was 150, this is going to be 160, all right? 160, boom, make it crazy. 160, boom, make it crazy, okay? 20 millimeters tall. All right, so let's take a look and see what we have going on here. You know, interestingly enough, I think based on this, it's already 20 millimeters tall. All right, so we're good with that. And we want to move its center to 11 millimeters above the work plane. So we want its altitude to be 11 meters. It's probably like 0 right now. So let's see if we can, oh, there's a 0. So we'll change that to 11. Poof. All right, so let's see what we got going on here. Yeah, okay. So if we look, we can see that this guy's hovering at about 3 millimeters, just a little bit above the surface. Not much, but there is a little bit of a gap there. And this guy's hovering at a humongous 11 centimeters. Okay, cool. So we've done that. We want to move it center to, okay, ta-da. So, we want to center these two, although they don't really say that in the instructions, but I'm pretty sure that that's exactly what we want to do. All right, so we want to take our slightly larger one, which would be this guy. Well, that's not working out so well for me, so let's try this. There we go. I guess you have to press the right mouse button to make things work. All right. So how's that looking now? Oh, look at that. So we have one cylinder over the other cylinder. So that's working pretty well. All right, what would we like to do now? Drag a cone, but keep it outside of the cylinder. Okay. So here's a cone. We'll put it outside the cylinder. Boop, just like that. I think what we're going to do is resize the cone. We're going to make the cone 150 millimeters in diameter and 20 millimeters tall. All right, so let's take a look and see what we're doing here. So height is already 20 millimeters, so we're taking care of that. Now we just got to worry about the 150 millimeter diameter. That's pretty huge. So that's got to be 150. Boom. And then this dimension, right here, has to be 150 also. Boom. So I've got a big honkin' cylinder. We're going to move its center to be 11 millimeters off of the work plane. So we want to give it a little bit of height. So we'll select it. Now where's our height for this guy? Height's probably at 0, so I bet if I do 11 on this guy. Pow. All right. So now we got 2 items floating at 11 and 1 item floating at 3. Okay, cool. All right, we're pretty good with that. Move it and center the cone on the origin. All right. Well, actually, before we do that, though, what we want to do with the cone is we would like to turn it into a hole. Boom. All right. It's a little bit freaky, a little bit weird, but now the cone is a hole, and now we want to center it on the origin. Click. All right. So this brings up an interesting question. Where's the cone? Well, interestingly enough, the cone is inside of the cylinder. So the cone and the cylinder are occupying exactly the same space. Now remember though, we turned the cone into a hole. All right, things get weird at this point in time. What are we doing here? What we're going to do now is remove the cone from the larger cylinder. So what we're going to do is we're going to select everybody. We're going to select all 3 objects that we have on there. Chink. Can you tell that we have? Well, yeah, because everybody, both the top and the bottom, have a blue line. And I don't know if I can do this or not, but I'll try really hard. If I zoom in and rotate just a little bit, you may or may not be able to see that the cone inside also has a blue line associated with it. So all 3 items have been selected by me. Thank you very much. But I want to unselect the bottom cylinder. All right. So notice the bottom cylinder has a blue line by it. So if I want to unselect it, I'm going to press the Shift key and select the bottom cylinder. Poof. Notice that this black plane, which is beneath all the things that we have selected, popped up. It had been below the bottom one, now it's below this, because all the things that we've selected are currently in this plane. You know, I may have actually unfortunately selected some stuff. So give me 4 seconds to redo exactly everything I just did. All right. Sorry, that was a mouse twitch that I didn't mean to do. All right. You're going to do Shift, deselect that guy. Black plane pops up. All right, we're good with that. Now remember, the cylinder had been turned into a hole. And what we're going to do now, of course, is group the shape in the cylinder. So we're going to go ahead and group. So what we really did, and I don't know if you can actually tell this, is if we did this correctly, we carved out a big section of what was in there because we had that cylinder there. Everywhere the cylinder was just got hollowed out. So now we're going to take this object, we're going to turn it into a hole. Hey, look at that. And what we're going to do then is we're going to select everything, which means we have the upper object and the lower object, and we're going to go ahead and group them. Boom. And if I did that right, we now have a bevel edge on our protractor. I'm not sure if you can actually see that or not. But that was the ultimate goal of all the machinations that we just did. All right, so we're going to assume that we have the bevel edge. What do we want to do now? This is actually a pretty simple part. What we're going to do is we're going to go like, like this. We're going to bring a box out. And we want to take up half of the circle with the box. I mean, that's just crazy, right? Just going to go like this. We're going to go like that. We're going to take it up to halfway. Probably should zoom in a little bit and make sure that we're actually at halfway. Is that looking pretty good? Yeah, okay. What we're going to do then is turn the box into a hole. We're going to select the circle also. And we're going to go ahead and group them. And guess what's going to happen to the circle? Pow. We just chopped our circle in half. It's gone. All right? Hot diggity. What are we going to do next? Well, we're going to bring out a cylinder. Hello, cylinder. Go like that. Oops, sorry. Do a little 3D action on that guy. What do we want to do with the cylinder? We want it to be 16 millimeters in diameter. So it's currently 20, so we'll change that to 16. And I'll change that to 16. We want it to be 3 millimeters tall. It's currently 20. Oh my gosh, so that's, we're going to slice that down. Chink. All right. And we're going to center it on the origin. All right. So how are we going to do that? Well, all we got to do is drag it. Poof, just like that. All right. Oh, and we want it to be 1.5 millimeters above. All right. So let's see if we can get some altitude on. Okay, altitude will be. Oh, there we go. 0 is what it is, so we'll make it 1.5. Boom. All right, we're just a little bit above. And we will now group it with the semicircle. So we'll go like that. We'll say, hey, these are really all part of the same thing. Poof, there we go. So what does it look like now? Just got a little bump down there. Okay, that's cool. Now what we're gonna do, well, we're gonna take a cone out. All right. And we're gonna flip the cone. Assuming I don't do all that well in this flipping stuff, so let's see if I can do this correctly. There we go, 180 degrees. That seems like that's a full flip, right? Yeah, okay, that's cool. I want it to be 7 millimeters tall. It's currently 20, so I'll change that to 7. I'm going to move it so its center is 2.5 millimeters above the work plane. It's currently 0. So make it 2.5. I'm going to turn it into a hole. Jink. I'm going to move it over here. I'm going to select my semicircle. I'm going to go ahead and group them. Now, how cool is that? I mean, that's just really cool, isn't it? If you come here and take a look at what's going on, you can see that there's now a little indent in there, right? I have to say that's pretty cool, actually. There we go. Oh, you can see it quite well there. So that just made a little something something, which of course is what you need if you're making a protractor. Thank you very much. All right. Now we need a window in this. Okay, so that's fine. So we'll drag out another cylinder. Hey, cylinder. And we're going to send it on the origin along the X and Y axis. So we'll put it like right. Ooh. Make sure we're centered. Are we centered? I'm not sure here. I'm going to say yes. Okay, so we're centered. Okay. centimeters in diameter. 110 and 110. Oh, what did I did something wrong there. That was the wrong one. Ah, this one. 110. Boom. Okay, so now oh. A little bit. There we go. Got it. I want to drag out a new box. Thank you. Center it on the right there. Got to make it larger than half of the new cylinder. So that's pretty good. What did I want to do here? I want to make a 15 millimeter wide straight edge ruler. Divide the a 74. That's 20. Here, let's see if I can get this right. It's 142. Ah. I think that's what I want to do. I want to move this to minus 22 on the y-axis. All right. What do I want to do next here? Make the box a hole. Group it with the new cylinder. And there you go. Wasn't quite what I wanted, but I got at least part of it there. All right. I think I've probably much run out of time for our getting together. I was going a little bit sideways on that, but you can see where I'm going on my protractor. I'm getting there. I just need a little extra to do the rest of it. And actually what's interesting about this particular project is that if you follow along, you can actually make a fairly sophisticated protractor, because what will happen is it'll actually have all the things that you need on it. So, interesting stuff here. Even as crazy as my protractor design is, if I decided I wanted to 3D print it, I can export it. All right. I want to do an STL file, I think is the type that I'd like to have. And I believe I just downloaded an STL file. Well, okay. So that means on my download directory, I've got an STL file. Here you go, protractor measuring angles. What happens if I open it up in my Windows box? A program that I literally don't know very much about seems to say, hey, that's an STL file. I would like to process it. It loads the file. And so look at this. I mean, it's my goofy protractor, and it's not really anything to write home about. And no, I wouldn't necessarily want to actually build it. But if I did, I have a 3D shape that's been downloaded in a data file onto my computer. So this is a shape that I could send to a 3D printer to have my sort of wonky protractor printed, if I chose to do so. What this means for you is that anything that you create in Tinkercad, you can export to your computer into a data file, an STL data file, and then you could take that data file, hook up your computer or somebody else's computer to a 3D printer, and you could have what you designed in Tinkercad actually printed out, turned into a physical item that you could actually hold in your hand. So now things start to get a little bit crazy if you think about it, because all of a sudden what that means for you, homeowners, is that you have the ability, if you so choose, that you could create anything that you really wanted. So if you've got knobs, for example, that have fallen off of drawers or cabinets, and if you know what they look like, you could whip them up in Tinkercad, create a design, download the file, and find somebody who has a 3D printer and print them out. Okay. If you're into playing games or something like that, and you'd like to have your own 24-sided dice, you can buy them. But why bother when with Tinkercad you could actually create your own 24-sided die and have it printed on a 3D printer? So, pretty much we all need lots and lots of little things in our lives, and ideally you can design it now using Tinkercad, and you can print it out using 3D printing. So I recommend that if you've got a little bit of time, go to tinkercad.com and check it out. It's a sophisticated program, it's free, and you can get a little bit of practice designing 3D shapes. And if you so choose, anything you design in Tinkercad can be printed out. All right, that's my presentation for tonight. Before we wrap things up, does anybody have any questions? No questions means I did a good job. I always like it when that happens.
Hello?
Yes. Is that Zane? What's up, Zane?
Indeed. Why do you prefer something like Tinkercad over a real CAD program like, say, Onshape?
Gotcha. So, short answer on that one. What's that? You making fun of my protractor? Yeah, so Zane brought up a very good question. So why Tinkercad as opposed to any one of, and there's lots and lots of other three-dimensional design programs and stuff out there. One of the advantages of Tinkercad, well, there's two, but one of them is, of course, that it's free, right? It's free. I don't have to install any software on my computer. All I have to do is go to the website and bam, I'm off and running and I can use it. So there's a lot of power in that. Another power in that program, there's a lot of people who use it. There's amazing things with it, and there's a very active community of people who support it. So if you choose to use Tinkercad to design something and you run into a problem, you don't know how to do something, you can't solve a problem, there's a strong community out there of people who use it who can probably answer whatever questions you'd have. So I like it because it's got a strong community and it's free, I guess would be the answer to your question. So great question. Great question. Those are the two things that turned me on to Tinkercad. So thank you very much for asking the question.
I have one other question.
Go ahead.
Or actually, well, one question, one comment. 3D build, of course, if you have a 3D printer, you have a slicer, which is going to take the STL file and generate your 3D view of the STL.
Mm-hmm.
There's no need for something like the Microsoft product. That's just a comment.
Right.
The other question is, does Tinkercad let me do things like make threads for screws, make threaded holes? Does it let me do things like make objects of rotation?
The answer.
I mean, Tinkercad seems to be based around pre-made shapes, whereas most of the other, the real CAD programs, you make sketches and rotate them and sweep them through things, make lofts and all that kind of stuff.
Gotcha.
So I'm trying to figure out what I can do, what I do with Tinkercad easier than I might do with, which I used to have access to, or Onshape, which is free also,
right,
and all done online.
There you go. And good questions all around. So Zane had asked about very, very specific things such as screws and things like that. The answer is, could you do it? The answer is yes, you could. Now, from the demonstrations that we went through tonight, I sort of showed you how you would do something like that. Basically, in the world of Tinkercad, you're pretty much removing things. So you would start with potentially a cylinder, and then you would have to remove things to create the threads that you needed for a screw and stuff like that. A good question. I'm pretty sure that if you go online, you could probably find somebody who has done it. And they would probably be able to explain to you better than I can exactly what you have to do. So no problems with that whatsoever. As far as some of the other things, interesting enough, I know that there's a number of projects out there where people have used Tinkercad to create gears. You know, they had a need. Some gear in something that they were using had broken. They had a 3D printer. They decided to make a gear to replace it. And Tinkercad was actually really very simple to do in Tinkercad to actually create a replacement gear. So screws, those are a slightly more complex type of thing. But gears, I know definitely that you can use Tinkercad to create. So thank you very much. Great question. Appreciate you asking it. Does anybody else have a question for me tonight?
I've got a question on 3D printers.
Go ahead.
Is there a printer we could buy for home use that's realistically priced and also actually functional?
Good question. The answer is yes, and I apologize. I don't have one to offer to you just because I don't have one at home right now. But there are a number of actually very good home 3D printers. Please understand, and this is the key thing that you want to keep in mind, your ultimate cost probably isn't going to be the 3D printer itself. You're going to end up spending the money on the filaments that you feed into the printer to create your things. And obviously there's a cost associated with that. One of the things that you'd probably want to study prior to purchasing a 3D printer for home is what types of filaments it can use. There's a number of different types of plastics that you can run into 3D printers. They all have sort of different characteristics, what they're good at, what they're good for, you know, making things that do and stuff like that, you know, high temperature, high stress, strong, etc., etc., etc. You just have to sort of figure out what, you know, the things that you're creating, what characteristics you'd like them to have, what type of plastic you would want to create with it, and then just make sure that the printer that you purchased had the ability to accept that type of plastic. You can get relatively sophisticated home 3D printers that can sort of take any type of filament, which is pretty impressive, but you obviously would pay a little bit more if you decided to do something like that. Okay, so the answer, and I apologize, I don't have a name to give you right now, is that there are a number of actually very good, reasonably priced home 3D printers. Now, one other thing that you'd want to consider if you're thinking about getting a printer for home is how large of an item can the printer print. So, you know, there is a workspace that each one of them has, and it defines how large of a thing. Lower cost 3D printers will be able to make smaller and only smaller items. If you're willing to pay more, you'll have a large, and you'll be able to make obviously larger items. So it's a matter of you thinking about what you're actually going to be printing. If your desire is to print chess sets, you can probably get any 3D printer because they're not going to be that large. But if you wanted to print larger things, like, I don't know, maybe doorknobs, something along those lines, you'd probably want to be very careful and take a look to make sure that the printer that you're interested in could print something that was as large as what you were trying to do. Great question. Thank you very much for asking it. Does anybody else have a question for me before we wrap things up tonight?
I've got one more.
Okay.
Is the STL file format, is that the standard? Is it one of many options?
Gotcha.
You mentioned the STL file format.
That's right. So it is one of actually several different options. It is sort of the standard. In other words, most 3D printers can accept it. You know, there are some other ones, and once again, each file format has its own advantages and disadvantages. A number of them are tied to very specific programs and stuff like that. But STL is sort of the generic, the lingua francaise of 3D printing and stuff like that, and most 3D printers will accept it with no problems whatsoever. So great question, yes. So if there is a standard, I'd say it's probably the STL file, but there are also a number of other file formats out there depending on exactly what products you're using to generate your output and also to do your printing. So great question. Thank you for asking it. All right, we've got time for one more question if anybody has one. Going once. Going twice. All right. Hey, everybody, thank you so much for joining me tonight. I really appreciate it, and I do apologize. we moved this meeting around a little bit, and I do apologize. That's all on me. But you guys stuck with me, and you showed up tonight. So thank you so much for doing that. I greatly appreciate it. If I did this correctly and I recorded it, hopefully I'll be able to post a video of what we went over tonight to the IEEE website, and we will go from there. All right. We are all done, everybody.
Thank you.
All right, guys.
Thank you very much.
Thank you very much, guys. Everybody stay safe and have a great evening, guys. See you later now. Bye-bye.